next guest, Bill Faloon, founded Life Extension in 1977. Today, it has grown into one of the world's largest consumer-based anti-aging medical groups. In 2017, William Faloon founded the Age Reversal Network, a private association dedicated to identifying and validating effective age reversal interventions. He has done all of this while battling the FDA and winning. Today, Bill will be sharing the results from his recent human age reversal studies and a new clinical trial that seeks to induce meaningful rejuvenation of aged people within a 12-month period. Please help me welcome to the stage Mr. Bill Faloon.
Thank you. Thank you. I'm going to talk to you about a concept that a couple years ago no one seriously ever considered. That is the concept of reversing biological aging in elderly people. And in order to enable you to pay attention to what I'm saying, every single slide I'm going to present them really fast. They're available on this website, age-reversal.net. So you can pay attention to the words and then look up the slides you're interested in when you get home. But the new paradigm, a true biomedical renaissance, is the prospect of rejuvenating elderly people in a statistically significant and meaningful manner. That is our objective. And we couldn't even consider this, couldn't even think about doing it until around the year 2015. This is the year that the prospect of reversing aging in old people turned real. Now, Time magazine that year published a very famous edition. This has been shown in many conferences where babies born in 2015 were going to live to be well over 100 years of age. What Time magazine didn't know at that time is research was already going on to enable people alive back then, and certainly alive right now, to potentially live for many, many hundreds of years. This is the cover of New Scientist, published earlier in 2019, talking about a cure for biological aging. And that's based on research that you have just heard talked about regarding telomerase, telomere lengthening, and many other treatment modalities that are going to make aging a relic of the past. So the most current special edition of Time no longer talks about babies. They're talking about aging itself no longer being a dreadful inevitability. It's just a matter of putting the pieces of the puzzle together that's going to enable us to take old people and rejuvenate them in a significant manner. And we're getting tremendous media coverage. The front cover, MIT Technology Review, proclaims old age is over. Now, the article inside was not quite as optimistic, but they gave a lot of the work that I'm doing and others some nice publicity and put it in front of some very high-level people so these people can understand if you're going to invest, donate, or participate, age reversal is where it's at. So if you wonder what's been going on over the last 4 years, maybe you've missed out on something, don't feel bad about that. Age reversal didn't turn real as it related to people anyway until around 2015. And that's when some very wealthy people in Silicon Valley decided, well, we've already accomplished the impossible. Let's just try to take on the challenge of aging and treat that as a technical issue that can be resolved. Founders of Google set up a separate subsidiary designed to find a way to gain total control over aging. They put a lot of money into that. This cover of Forbes magazine, this individual, Osmo Kaibar, a multi-billionaire, he's got a company putting huge amounts of money into anti-aging research. Mark Zuckerberg has pledged 99% of everything he has, and he has a lot, to finding a cure for every age-related disease that exists. Jeff Bezos of Amazon, he is looking at senolytics as a way to treat aging, as a way to reverse aging based on a lot of information I'm going to convey to you today. And possibly the largest fundraiser so far, an individual named Jim Mellon. He set up a company called Senescence, and he's raised well over $165 million to fund research aimed at enabling people to live to be at least 150 years of age. So you've got all of this amalgamation coming together, and a lot of it is based on the work of Dr. George Church at Harvard. He received some interesting publicity back in 2015. He is an expert on CRISPR-Cas9 gene editing technology. Once that technology is perfected, A cure for aging is likely to soon follow. So the Washington Post talked about this in 2015, a Harvard professor, and he has continued to get very favorable coverage, and that has resulted in him getting lots and lots of money to do his research. George Church, as far as I know, is an immortalist like I am. He wants to live for an indefinite period of time, so his research is more than just trying to prove a science or make some money. He personally wants to benefit, and he's also stated he may be one of the first human study subjects to have his genes edited so he becomes a biologically younger human being. So year 2015 is the year that a critical mass of donors, investors, physician scientists decided it's time to live forever. This is unprecedented. It's never occurred before in the entire history of me working at the Life Extension Group since 1977. We founded that back 42 years ago. I never thought I'd be talking to a group of people in my lifetime about putting aging in reverse. But what happened in 2015 is Nature, and this is a scientific journal that is paid attention to by the media. If you see something on Fox News, CNN, the Wall Street Journal, a major medical advance, it's often published and editorialized in Nature. And what they talked about in 2015 is the consistency of the data that when young blood is circulated into old animals, the old animals grow younger. And Nature said, well, it's time for us to start testing this in people, and that's exactly what started happening. Around 2015, 2016, the most significant, most prestigious research universities in the world are studying the effects of young plasma in older people and how that may enable rejuvenating effects to occur. Johnson & Johnson put $50 million into a study at Stanford University where they're looking for the constituents in young plasma that can reverse degenerative brain aging. A huge, huge undertaking, and they're getting some very interesting results. They tried some results with just teenage blood, teenage human blood injected into old animals. Well, it rejuvenated the old animals. This is proof that the concept of something in young blood has powerful rejuvenating effects when administered to older organisms. In this case, we're looking at young teenage blood put into old mice and their aging process going in reverse. Absolutely spectacular. As Bill Andrews said, we just don't want to see biomarkers. We want to be active. If we're going to reverse aging, we want to start behaving younger, and that's exactly what happened. Fresh, young, teenage blood enabled the animals to scamper around a cage and start to behave like they were young mice again. The blood from teenagers put into these old mice enabled neurogenesis, new brain cells to grow, so that horrific atrophy that occurs with aging in our hippocampal region of the brain, it can be reversed with young plasma constituents. If you wonder what happens when young blood circulates into old animals, well, they live 10 to 12 human equivalent years longer. So longer lifespan and systemic regeneration. We already know how to do it in a laboratory model. It's just a matter of transferring it into humans. Study came out this year, which was absolutely dynamic. They looked at a more efficient way to take those young blood constituents to rejuvenate old mice. And what they did is they transplanted bone marrow from young mice into old mice. And the impact was absolutely incredible. This chart shows microglial cells. These are a brain cell that helps maintain our neurons. And you can see at the far left, a young mouse, the cells have branches extending from them like a healthy young tree. Well, this represents the synaptic connectome that enables these cells to communicate with each other. And you look at the old mouse, and it's all shriveled. It's shriveled like an old person with sarcopenia and osteoporosis and cartilage degeneration. It's just what happens with aging. We know that. Outwardly, we know that happens. It also happens inside our brain. But when they took young bone marrow and transplanted into the older mice, look at that slide to the far right in red. The synaptic connections were restored back to the same number, the same type of structure as a young mouse. So don't let anyone ever tell you aging cannot be reversed. It's already being done in the laboratory model, and yet most of the public still thinks it only goes in one direction. And again, if you're wondering, well, what happens when you regenerate the microglial cells of those mice? Well, there's systemic regeneration. They start to scamper around a cage. This slide shows the activity levels of old mice with young bone marrow transplants. And the lower slide to the far right is the old mice with young bone marrow. They're scampering around the cage like the young mice, and that's the box on the upper right-hand corner. So we're seeing that young blood, young plasma constituents can regenerate aged brains and systemically regenerate our body. Now, what's been happening based on all I've been talking about so far is some people have been self-experimenting with human plasma up to 35 years of age, and my advice at this stage is hold back on that. We haven't seen consistent results with middle-aged human plasma being put into old people. In other words, we need something somewhat better. So even though some people are still paying every couple months for plasma that's not particularly young, we're not seeing the rejuvenating effects that we hope we would. But what we're also looking at are the animal studies showing that very young plasma can have a much more meaningful impact. Now, the Stanford University scientists, remember they got that big grant from Johnson & Johnson, they did take middle-aged plasma and they put it into old mice, and there were some reversals of brain aging noted. But when they took very young plasma, 15-day-old mice compared to 15-month-old mice, there was systemic rejuvenation. Broad-spectrum, pronounced regeneration of neurological function and structure. And if you want to know the difference between a 15-day-old mouse and a 15-month-old mouse, well, here's the graphic. That mouse to the far right, that tiny little 15-day-old mouse, has all types of regenerative proteins in its serum. Where the older mouse, that one is middle-aged, well, it looks like an old person, frankly, who's got metabolic syndrome and obese, type 2 diabetes. You don't want middle-aged blood put in your body. You want very, very young plasma protein constituents. And the fantastic news is they identified two specific proteins in young serum, very young serum, thrombosbondin 4 and spark-like protein 1. Those two proteins, they believe, were responsible for these powerful rejuvenating properties. And what is so exciting about that is they know how to make these in the laboratory through recombinant technology. That means we don't have to go and raid nurseries looking for 2-year-old kids and suck out their blood. We don't have to do that because they've already identified the proteins most likely responsible, and they can already synthesize them. So 2 to 3 years from now, we may be having some of these very young proteins put into our aged bodies and enjoy these incredible rejuvenating properties. Now, as it relates to what we can do right now to extend our healthy lifespan, a study came out just a couple months ago where 3 different drugs were used to extend the lifespan in fruit flies by 48%. And you wonder, well, these are fruit flies, is 48% really a big deal? Well, yeah, it is, because typically when they do a fruit fly study, they see a 5 to 20% lifespan extension if the therapy works, and they're all excited about that. Well, this particular protocol enabled 48% extensions of lifespan. And the 3 compounds, rapamycin, which is available, by the way, in the United States at a price you can't afford, but it's available from offshore sources at very low prices. Lithium, low-cost dietary supplement, you can buy that anywhere, and a dasatinib-like drug, which is also available. 3 different compounds administered together, extended lifespan 48%. Well, what happened when they administered just one compound? They got an 11% extension. That's good, but not really that good, because 11% means there's going to be a time when we run out real soon. 2 drugs, hey, 30%. That's pretty good, but when they put all 3 of these together, they got that 48% increase in healthy life extension. Very, very significant, because it validates what our age reversal network and what our life extension group is doing right now to help rejuvenate older people. We're using almost 12 different therapies in a stair-step approach to reverse every pathological mechanism of aging we can identify. 12 different interventions, and we're doing that in a stair-step approach. We suggest, first of all, activate AMPK. Now, you can do that through severe calorie restriction, but I think metformin is a little bit easier to take. And if you can't take metformin, there are certain nutrients that have AMPK activating properties. Your body accumulates senescent cells as we grow old. Senolytics are documented right now to reverse many, many aspects of aging, including in people. You, of course, want to restore your levels of nicotinamide adenine dinucleotide, NAD+, and remove the toxic debris that's inside your cells through autophagy, and that's how rapamycin works. And then the biologics, that's step number 5 on that chart. And biologics can mean stem cells, stem cell exosomes, some of the gene therapies that Bill Andrews just talked about. Step 5 is the biologics. And we think if you do all that, there's a good chance you're going to live to 2030 when Dr. George Church at Harvard believes a cure for aging will be available to all of us. And if you're wondering, is this being demonstrated in people at all? Well, yeah, big time. A study that our Life Extension group helped fund using 3 different drugs. These are somewhat different than the fruit fly model, and this got a lot of publicity earlier this year. They were able to reverse aging in people by 2.5 years. First time in history, by the way, something like this has been done. And the 3 compounds they used, individualized doses of human growth hormone for only 12 months. We're not recommending consistent growth hormone use, just 12 months of growth hormone, DHEA, you can get that anywhere, and metformin, prescription drug, but people are nowadays getting prescriptions more readily. Publix, by the way, will give away metformin if you just walk in their store with a prescription, or you can order it offshore. You can get these drugs very inexpensively, and what we're investigating now is a low-cost source of human growth hormone so that anyone who wants to replicate the study done here, and that study, by the way, is going to be expanded, and I'll tell you before the end of the talk here how you might be able to enroll in that study. You may be able to reverse your aging process by 2.5 years. This got international publicity, by the way, and it demonstrated again that multimodal approaches, there's not a single therapy that's likely to reverse your aging process at this point. It's more than likely going to be a multiple therapy. Now, this is the type of historical data that scares me. The delays in implementing proven therapies. Edward Jenner discovers the cowpox vaccine can inoculate people against smallpox. He had to work very hard himself in order to move that through Parliament in order to get that to a point where the British government finally recognized it. But look at that time scale. It took over 100 years from the time the cowpox vaccine was discovered to implement it so that no one in England died of smallpox anymore. And you know what? We don't have that kind of time. We just don't have that kind of time to wait because we're aging right now. I turned 65 years of age this year, and it's pretty much like I'm a duck in a shooting gallery. Every disease out there, every single one, I'm no longer too young to get. I fit the criteria now as far as a risk factor. I'm a certain age. By the way, how many of you are taking metformin right now? We highly recommend this drug for a lot of reasons. It has some potent processes in enabling you to be healthier now. It may enable you to lose a little bit of weight, by the way, but it has some potent anti-aging properties. Anyway, metformin was approved in England in 1958. Now, it didn't get approved in the United States until 1995 for diabetics. But our Life Extension group recommended in 1995, well, you have access to metformin. Why don't non-diabetics take this drug to slow their aging and reduce their risk of progressing to full-blown type 2 diabetes? And it took until year 2015 for the first clinical trial of an anti-aging drug to be approved. FDA did approve a trial on metformin in 2015, and that's an expensive study. It took until this year for the $70 million to be raised to do this study. You look at that time frame and you realize we need to accelerate age reversal research. We cannot let these delays occur. You look what was published back in 1995, these dramatic risk reductions in response to diabetics using metformin. And our Life Extension group said, well, if diabetics are getting those benefits, we want them too. Because if we're over the age of 20 or 30, we most likely have a little bit of insulin resistance or a lot of insulin resistance. And metformin is an AMPK activator. It works by several mechanisms to break down insulin resistance. So this data published January 1995. Now, we recommended the metformin in our Life Extension magazine back then as an anti-aging drug. You also see other drugs on that list that are now approved. But back then, they weren't. FDA wanted to put me in jail forever for publishing this kind of information in Life Extension magazine. And if you're wondering, well, why were they so upset about that? Remember, in 1995, virtually no internet. People didn't know where to get anti-aging drugs for low prices. So when we put it in our magazine, it upset the bureaucrats. We didn't care. We published this every single month to let people know what was going on. And the data continues to substantiate the incredible benefits. Here we have JAMA publishing an article just a couple years ago showing that people who start metformin before type 2 diabetes is diagnosed, they reduce their risk of progressing to diabetes by as much as 58%. And then also that little side benefit that may persuade some of you who have problems losing weight, you can lose a little bit of weight if you take metformin and cut back a little bit on your calories. And metformin makes that easy. It often reduces your appetite. So this is a drug we highly recommend, and do it in the context of everything else we recommend, so you're not just taking metformin by itself. Now, as it relates to cancer, potent anti-cancer properties of metformin. Cover of Life Extension magazine 9 years ago, we were recommending metformin as a potential adjuvant cancer treatment, and also for people to take metformin to reduce their risk of contracting cancer. And guess what? The data bore us out. It shows that colon cancer patients taking metformin did far better, in some cases 4 times better than the non-metformin patients. If this was the only slide you saw today about metformin, you'd say, I'm going to start taking that because I want to reduce my risk of getting colon cancer. I don't want to wait till I get it. But if any of you are cancer survivors, you really ought to tell your oncologist you're going to get on metformin as an adjuvant therapy, meaning you're going to use that in addition to everything else you're doing. And as it relates to cancer prevention, MD Anderson showed that about 10 years ago, that pancreatic cancer, nobody wants that one because even our group has a hard time trying to deal with that one when it's presented to us. Nonetheless, people taking metformin, a 62% reduction in their risk of contracting pancreatic cancer. If that's all metformin did, by the way, is reduce pancreatic cancer risk, I'd be taking it. And I've been taking metformin since around the year 2000. But the good news about research is it's starting to take off. And in 2015, the world's first anti-aging drug trial was announced, and their objective with this metformin study is to enable people to live a real long time. And senior citizens were scrambling to get into this trial. They didn't know what you know in this room, and that is you can start metformin right now. You don't need to enter a clinical trial and risk getting a placebo. You can get your metformin right now. But the Wall Street Journal reported that seniors were pouring in. But remember, they didn't get funding for this study until just a couple months ago, and they don't expect results till around 2023, 2024. We don't have that time to wait. And here's an example of a catastrophic loss of life caused by the FDA's delay in approving metformin and other factors, not just the FDA. The pharma companies were dragging their feet, too many people. But if metformin had been approved just to treat type 2 diabetes when it was approved in England, 4 million American lives could have been spared. And to put that into proper context, that is more than all of the deaths of all the wars this country has ever fought put together. That's how many people died because of the bureaucratic delays in getting metformin approved in the United States and made available to American type 2 diabetic patients. And that's why these delays are so frightening. We know already ways to slow down and partially reverse aging. We already know those ways. I'm going to show you in just a minute. We just don't have time for age delay. So that's what motivated us to launch the most ambitious biomedical study in the history of medical science. The name of the study is Vitality in Aging. And the outcomes of this study, we're looking in just 12 months to achieve statistically significant and meaningful biological age reversal. That is the objective. 12 months from now, I hope to be talking to you with the results we get from the study that incorporates everything we have available to us right now to reverse aging in people. The cost of the study, $550,000. You may be wondering, how can you do a study this big so cheap? Well, the doctors are donating their time. The laboratories are giving us subsidized prices on the blood test. We've got volunteers helping us across the board. This study should cost over $10 million, by the way. We're doing it cheap because of the donated services. And this is the good news. I started a charity January of this year called the Human Age Reversal Project. We wanted to raise $550,000. we've raised $627,000. So we have exceeded our budget, which is good news. That means we can do more tests and add more interventions to the study. This is the charity, by the way. If you're somebody who can afford to write checks to charity, I just ask you maybe consider this as one of your priorities. Every cent you put in here supports research. None of it goes to my pocket or anyone else's. It only goes to support the research expenses. Now, here's what we're going to do to try to reverse aging in 12 months in about 50 older people. We're going to target 5 different pathways that I think most of you are familiar with. We want to lengthen telomeres if we're able to. We want to remove senescent cells. We, of course, want to target the beneficial pathways that occur when you restrict your calorie intake. This is another chart to just give you an idea of what our premise is behind this study, and that is attack every known mechanism of aging and put that mechanism into reverse so that the person systemically rejuvenates themselves. So this is an open label trial. There's no placebo group. There will never be a placebo group in any trial I'm involved in, because a placebo group is just going to progress with degenerative aging and die. And to me, it's just unethical. We know aging, it takes its course. We know how to measure biomarkers. We know how to measure meaningful improvements, and we anticipate launching it in January. A month from now, we plan to start bringing the first group of people in. Now, 360 people have applied for this study, and we only have room for 50, so we're pretty much filled up here. But some people in this room have already applied, so they may get a call from us next week or two to know you've been selected, and you're going to get about $10,000 worth of treatments and tests, by the way, for free by virtue of the donations that came in. So just to review these interventions, I think everyone knows that less you eat, the longer live. I mean, calorie restriction, absolutely proven to work. And this study, published in 2018, really interesting. It showed that if you just reduce the amount you eat by 12%, is there anyone here who can't reduce it 12%? I mean, that's not much, but you improve your biological age score by 1.5 years. And because of this, we're going to be putting into place calorie restriction mimetics. These are compounds that mimic the beneficial effects of calorie restriction. And you can see the target on the left that we're seeking and the intervention. And you'll see metformin is in there quite a bit. You'll see a precursor to NAD called nicotinamide riboside. You'll see glucosamine that you're familiar with. But these are the calorie restriction pathways that we're going to target so that even in study subjects who won't reduce their calorie intake, they're still going to get a lot of the benefits. So that's going to be important. And then the mechanisms, again, of calorie restriction, increase AMPK. You want to improve autophagy, cleaning out that cellular waste products that accumulate inside your cells, boost your sirtuin proteins, and of course your NAD plus levels. You want to boost those inside your cells, and you want to decrease excess mTOR, excess insulin, excess IGF-1. These are the targets of the CR mimetic pathways. Senolytics, very important to everyone here. We have a senescent cell burden, unfortunately, that's accumulated, and it will thwart almost any other intervention that you're going to employ. You may spend a whole lot of money on some stem cell treatments, and those senescent cells are going to eat away and destroy the healthy young stem cells put in your body. So what they found is if you have one senescent cell in a group of 7,000 to 15,000 healthy cells, that one senescent cell is enough to induce degenerative aging. It's like a contagion. One bad cell in your body, and they eat away to healthy cells. They ignite chronic inflammatory signals. They're just very, very dangerous. And the media has given a lot of publicity to this around the world. They call them zombie cells. You want them to die. You don't want to keep them alive in your body, but they linger there. You don't want to have senescent cells in your body. And some human research published earlier this year showed some partial benefits using dasatinib and quercetin, which is part of our protocol, by the way, to improve pulmonary function in people with pulmonary fibrosis. We think the indicators go a lot more than that. And what's really fascinating is a lot of the interventions you hear about, they'll start animals at a young age, and those animals live a long time. But I don't see any babies in here. So we need therapies that can work when people are in their elder years. This study showed that when senolytic therapies are introduced to remove senescent cells, animals, the human equivalent of 75 to 90 years of age, were benefiting. That means we can start benefiting no matter how old we are in removing our senescent cells. So this is tremendous, and it's made it into the major medical journals. American Medical Association, JAMA, they published an article about senolytic therapy potentially reversing aging, and just 2 months ago, The New England Journal of Medicine, they published an article for the first time I've seen about reversing the aging process. This is making it to the mainstream. It's no longer Bill Faloon in 1977 talking on some radio talk show, which I did, about people reversing aging and people just kind of joking about it as if it was never going to happen. It's making it to the mainstream. The major medical journals are recognizing it. So this is the second intervention in the clinical trial that we're going to be doing, a senolytic cocktail of the drug dasatinib, high-dose quercetin, and a flavonoid called fisetin. Those three together, we believe, will remove enough senescent cells to make a meaningful difference. And our third intervention, we need to reduce and resolve chronic inflammation. There's going to be high doses of fish oil. We're going to boost the omega-3 index. That's a blood test that measures optimal omega-3 status, which should be over 10%. So we're going to make sure everyone in this study gobs down enough fish oil, be it liquid, capsule, however they want to get it. They're going to push their omega-3 index up to 10%. And then we're going to put something in known as a pro-resolving mediator that helps heal the damage that chronic inflammation inflicted on our tissues. So we're both going to reduce the inflammation and resolve the damage that it causes. We're going to attempt to elongate telomeres through healthy lifestyle choices that most of you are aware of, by the way. I've talked to a number of people here for the last couple hours, and I realize you're a very intelligent group. And I didn't really know what kind of group to expect when I put this presentation together. But the bottom line is, if you want to at least reduce the shortening of your telomeres, reduce that, all the good health practices that you're aware of, including ingesting lots of omega-3s, this can reduce telomere shortening, and we've got some evidence anyway it may induce some telomere lengthening. So we're going to test telomere length baseline, and after 12 months of all the different interventions, we're going to see, were we able to extend the length of the telomeres. And the fifth intervention is aimed at restoring youthful DNA methylation. This is absolutely critical if we're going to reverse aging in people in a meaningful way. Not only does DNA methylation have a lot to do with the pathologies of aging, it enables us to measure how well we're doing. We can use DNA methylation to see, did we put people in reverse as related to aging, or did we do nothing? So this is a way to measure the epigenetic clock. It's available to us from 4 different laboratories, by the way, and we're going to use 4 laboratories, not just one, to validate whether we are really reversing aging in our clinical trials. And again, what we expect to do that, rapamycin, which is extended lifespan in virtually every animal model that's ever been studied, metformin, and other calorie restriction mimetics. We've been talking about rapamycin for a long time, but the National Institute of Health, they're going to spend some money in a good way, $23 million on a study of 10,000 pet dogs. If you have a pet, by the way, who's getting old, you may be able to enroll your pet dog in a study. They're going to do a complete genetic sequencing, and out of the 10,000 dogs, they're going to give 500 of them rapamycin to see if the rapamycin does not reverse aging in your pet dog. And the reason they're doing that is it's already working in proof of concept animal studies. So this is great news. We're seeing the National Institute of Health finally putting some money into some good research and not just education or kind of research where how can you make people function better in a nursing home situation. The idea is to reverse aging, and we've got the technologies today that we didn't have 5-6 years ago. 5-6 years ago, I couldn't be here talking to you like we are right now with potentially effective ways to rejuvenate older people in a meaningful way. Now, the different aging biomarker tests, and again, these are being given to us at very low prices. It's the only way we can afford to do a $10 million study for less than $600,000. There's newer DNA methylation tests. There's a new telomere length test that Johns Hopkins has developed, and they're giving that to us at a subsidized price. UCLA, University of British Columbia. We're getting a group of universities, a group of physician scientists. We're all on the same team. We're all growing older. We got to figure out a way to reverse it, and we can't fool ourselves. So these tests will be done baseline and throughout the 12-month period to see if we're not reversing aging in older people. So again, the great news is, and I've given a lot of talks for the last 4 or 5 years, we didn't have any money. We didn't have any money to do the kind of research we needed to do, and we received donations over the last 12 months that exceeded what I was seeking to raise for this specific study. Doesn't mean we don't need more money to make it better, but the good news is we can afford this study. We've got the money in place. So again, this is the charity I set up in order to make this research happen. We do intend to expand research as donations come in, and this stair-step approach is pretty much going to be what we implement for for the 50 people in the Vitality and Aging Interventions trial. Activate AMPK, again, metformin, easy way to do that. Senolytic therapy, restoration of NAD, the autophagy induction with rapamycin, and then biologics. And you all know a lot about those stem cells, access to potential exosomes. What we're going to do after 12 months is validate which ones work, which ones don't, and we can move on from there. So going back just 4 years ago, this article in the Washington Post, Dr. George Church talking about finding a cure for aging. It sounded rather ludicrous back then, and as we move forward with CRISPR-Cas9 technology, and he's not the only one doing it, by the way, we're seeing it work. We're seeing it work in animal models. But again, history is such a powerful lesson as to what not to do. 1497, someone discovers citrus can cure scurvy. Wow. And it takes 150 years or so for someone to do a study. 150 years of people dying of scurvy before someone does a study and says, hey, it really works. And then another 150 years or so, someone does a study and the study was flawed. They used oxidized lime juice and that destroyed the vitamin C. And when that study failed, they proclaimed the citrus cure doesn't work. No need to take citrus if you have scurvy because it's not going to cure you. And it wasn't until 1932 that they discovered, wow, it's the vitamin C in the citrus that was curing scurvy. And you know, no one here can wait 400 years. We can't wait 40 years. We need the technology developed right now. We cannot delay age reversal research. And what I conclude most of my presentations with are the people who could have put substantial money into research that would result in them staying alive and the rest of humanity. And even though they may have been philanthropic, they may have donated to a lot of different charities, they didn't target specific projects that could have put them in reverse. And people at relatively young ages with many, many billions of dollars wind up dying from causes that could have been corrected, could have been intervened with had they just opened their eyes and gone beyond conventional medicine. I'm hoping never to be on one of these slides, by the way, because I've put, well, over $200 million of my money into research. I believe that's the only charitable cause that's worthy of funding as it relates to benefiting all of humanity is aging research, finding a way to cure biological aging. And T. Boone Pickens, I think most of you in the financial community know who he is. He is an example of many, many billionaires I've met who I'm suggesting, you know, if you wrote a check for $100,000, I could do a study on a drug, and then you would know if that works or not. And they say, you know what, Bill, I feel okay today. In fact, I'm doing so great at my age. I'm 88 years old. I'm doing fantastic. You do your research, Bill. I'll follow you, and maybe I'll write a check later. Well, a year after he said he felt immortal, well, he suffered a series of strokes, a fall. At age 91, he's dead. Now, this is a very generous guy. I mean, so generous, he built a football stadium. $260 million to build the Oklahoma State University football stadium. Now that's a nice thing to do, but just a small percent of that put into aging research could have kept T. Boone Pickens alive. He didn't have to necessarily die so young, but this is where he put his charity money. And I see that with other people. They put it into art museums and theaters and different nice things to do, but they don't attack aging. Now here's an example of someone doing the right thing. The Soffer family, they're somewhat famous in Miami. They wrote a $25 million check to the University of Miami to do stem cell research. Well, that's a good way to spend your money. That could benefit the Soffer family and you and the rest of humanity. So this is what we're encouraging people who are very philanthropic, that instead of donating to so many of these other charities, focus on what's going to keep you, your loved ones, and all of us around. So again, this is our little charity. It's nothing big as far as the size of it, but the difference is it's very focused. Every cent that goes into this charity goes into clinical research that will carefully monitor whether we are rejuvenating aging in older people. And just to go back 10 years ago, I had a group of people who wanted to get together because we were kind of doomed. There was nothing we could do to reverse aging that we knew for sure would work. So I brought together all the scientists who wanted to participate in a 3-day weekend. I paid their travel expenses, the hotels. It was $60,000 we spent. And after 3 days of intense discussion, instead of hearing what you've been hearing on this stage, there was nothing. Nothing. There was no validated way to reverse aging in 2009. Move forward just 10 years, and you look to the right. Those are the 12 age reversal interventions that our Age Reversal Network, our Life Extension Group. That's what we're working on right now, in addition to what you saw Dr. Bill Andrews talk about and what you're seeing other speakers talk about. In 10 years, we've made this kind of improvement. This is a true biomedical renaissance. There are multiple ways that we can potentially reverse aging right now, and what our group is doing with the Vitality and Aging's Interventions trial is incorporating virtually everything you see on the screen into a step-by-step protocol to enable people to grow biologically younger if the trial turns out successful. And the great news is, the world is catching up with us. They are rebelling against this notion of only living to be 80 or 90 years of age. And they are rebelling against the progress in science that is not occurring, even though it's working in the laboratory, it's not being translated into clinical practice. This is all great news. I'm going to conclude this with a quote that came out of the New England Journal of Medicine just a couple months ago, and it relates to the speakers on the stage, and it relates to you in the audience. That without daring innovators, disruptive thinkers, and voluntary patients, I think a lot of you are self-experimenting. You're basically volunteering to see how well metformin works and other types of interventions. Well, medical progress would not occur. You need the innovators, the disruptors, and you need volunteers, people who are willing to participate in clinical studies to see if their aging process cannot go in reverse. So if you're interested in enrolling in our clinical trials, again, the one we're initiating in January is filled up, but we are going to be doing future ones. As more money comes in, we'll be launching new trials. This is the place to do it, age-reversal.net. You can just give us some basic information, and then we'll send you an email when we're launching a new clinical study, and you can determine whether or not you want to participate in it. None of us has time to delay. I've done nonstop work since around 2014, when the prospect of reversing aging in people became clear to me. And just to remind everyone how people died in 1900, we don't die from tuberculosis very much anymore, or pneumonia at young age, or diarrhea. In 1900, that's how they were dying. We've eradicated that, and we're living longer right now, but nowhere near long enough. These, again, historical examples of what happens when there's delays. The fact that penicillin was discovered in 1928, published in 1929, not widely available till 1946. We're in the same dilemma right now. I'm talking to you. I presented right now potential penicillins as it relates to slowing or reversing aging, and the rest of the world, they don't know about that. And the delay with penicillin, well, millions and millions of people needlessly dying, including so many children. It's hard to imagine the anguish. Infectious disease, and penicillin was already discovered. It just wasn't made available. So the biomedical renaissance began circa year 2015, and the Time magazine projection, well, they were just a little bit too pessimistic. Living to over 100 at this point is now no longer confined to the babies born today. It's potentially available to us. And again, this is the website if you want to enroll in clinical trials or just receive age reversal updates that we send out to let you know how well everything is doing. I want to thank many of you, by the way, for supporting us, our Life Extension Group, since 1977. We've used proceeds from everything we do to fund research. That's what money is meant for, as far as I'm concerned. So again, the entire presentation is available on this website, and I'll be hanging around most of today, so if anyone has any questions, I'll be happy to answer them. Don't hesitate to come up to me.